Hello and welcome to this quick electrical checkup and repair for the Goodman ARUF37C14AC inside unit and the Goodman GSZ140361KE, that is the outside unit. I am going to start with the inside unit. I am going to be checking the main relay, the wiring, and the control board, and I'm going to check those and make any repairs. I did have this unit go bad on me recently due to perhaps an electrical fault or some sort of electrical surge or even a lightning strike. I am not sure exactly, but also there's a chance that I did have a loose wire on one of the relays and it caused it to burn up, spark and burn up, arc, and fault, and the air conditioning stopped coming on altogether. It did not come on. So if you're having an issue with your AC just not coming on at all, this tutorial may help you find the problem and perhaps repair it yourself by purchasing the parts and avoiding the high cost of labor and parts that HVAC companies and technicians are basically giving you out there. Just to start, this is the label on the inside unit. The inside unit that you have may be in a closet in the first level of your home or the ground level if you have a multi-level home, or it may be up in your ceiling area, up between your ceiling and your roof, which is also called an attic. So look for that in either of those two locations and you'll find the unit. The unit is going to have a label more or less like this one, and that is what you need to order parts, to find a parts list, parts diagram, and to know exactly what model. These units may have different sizes, different voltages, different models, different features, and the part number may be slightly different for you or for your location, the unit that you have. So look for that. Before you do any kind of check, before you remove any panels or even go near the unit, make sure you locate the disconnect, the electrical or power disconnect. In my case, it looks like the one there marked in the middle of the screen. Make sure you locate this unit disconnect and make sure you disconnect it. But before you disconnect it, go down or anywhere your electrical panel may be, locate your electrical panel and switch off the breakers for your air conditioning. It may be labeled or it may not be labeled, but make sure that you do turn your breaker off. This is to avoid, of course, electrocution, severe injury, or even death. So please turn off your breaker for your air conditioning. There may be more than one breaker. Make sure you shut them all off. And then come up and locate this disconnect, or go wherever your unit is. That disconnect should be located near the unit, near the inside unit, and you will have to shut it off. And the way you do that, shown here in this particular model, you have to pull that red tab that you see on the screen, pull it, and your disconnect is deactivated or disconnected. You may have a disconnect that has a lever. Make sure you shut the lever to the off position. You may have any kind of other model of disconnect. It may be fused, it may not be fused, so there are different models. Make sure you look at the one you have, follow instructions, and make sure you shut off any kind of power going to that unit. Be aware that there will be power going in and out when the disconnect is on, like in this case on the left side. So you will have power on both of these cables. In this case, once you disconnect it, be aware that there is still power here going in. However, there won't be power going out. So make sure that you have a tester to ensure that there's no power going to the unit once you disconnect once you shut it off. And of course, there are many kinds of voltage testers, power testers. Make sure you choose one that you are familiar with or you can become familiar with and safely use. If you're not comfortable working on electrical equipment or powered or energized equipment, I recommend you do not do this job or follow any of these instructions, and just find someone that is qualified, like an electrician or HVAC technician, or someone that is quite familiar and comfortable working with energized equipment. Of course, once you the disconnect here, once you shut it off, there should not be any power going to the inside unit. So once you shut off your disconnect, test for power going to your inside unit. In this case would be power going from the bottom here. That cable, that big cable or wire that goes to the unit is the one that carries the power, the voltage to it. Make sure with your voltage tester, you test at this location. Make sure there's no power going to the unit. Once you determine that there's no power going to the unit, go ahead and take this panel off. There should be about 6 screws or bolts that you can remove, marked here in red. And once you take the panel off, it should expose the inside of the inside unit. Again, we're looking for problems that could prevent the inside unit from turning on. And just quickly, briefly, to describe what could possibly be causing a inside HVAC unit not coming on. It could be a few things. One of them, it could be a fuse that has blown or burnt. It could be a breaker that has tripped at the breaker panel. It could be that the thermostat stopped working. The thermostat is faulty, burnt, or broken, and it has stopped working. It could be that you just have no power in the house, and it could be also that there is a faulty part within the unit or multiple parts. Could be a bad relay, burnt, broken, or bad relay. Could be a bad, broken, or burnt control board. It could be again a fuse within the unit. There are a few fuses within the unit. It could be a loose connection, whether it's a wire, cable, or a connection to the control board. It could be a broken wire. It could also be a short in the wiring, meaning that there is some exposed metal or copper of a wire that is touching either another wire or it's touching the frame, shorting out the wire and the electrical system of the unit. It could be several things, including the ones I just mentioned. It could be also a motor. As you can see, the motor is seen there. The blower motor, that's just burnt, disconnected, faulty, broken. The connection to the motor may be loose. Again, there's many reasons, but we'll go through a few here that we can go and check. In this case, I'm assuming that you have already checked your breakers. Make sure they're on. I'm assuming that you have checked. Make sure that the disconnect is not the problem or was not the problem. Make sure that the fuse in the disconnect, if it had any fuses, are good. There are ways to check fuses that are in a disconnect. Make sure again that you turn off your disconnect before you remove fuses from the disconnect to check those. And I'm assuming that you know that you do have power in your home. So once you clear all those, once you know that all those things are good, then you can go ahead and keep going and checking for other problems, which we'll again go through in this tutorial. As you can see here, you want to check for, once you open the panel, you want to check for any loose, disconnected, untied wiring. As you can see, these wires here came out as soon as I took this panel off, and I noticed it has a few wires here with wire nuts. They call them wire nuts. Some of those may have come loose. Make sure you look at all of that and go ahead, and if you know what wire came loose, tie it back. If you're not sure, if it's multiple wires that came loose and you're not sure what wire went where, then look for help identifying and repairing or tying those wires back up. They should match in color, but that's not always the case. So make sure that you are familiar with the wiring, what wires go where, what their function is, what their voltage is, and make sure that before you do any connection, any kind of tying of wires, you know and are very sure that that wire is supposed to be tied with the wire that you are tying it to. Once you open up the panel, the unit, take the panel completely off, go ahead and again go through every connection, every component, every area, including this board, and look for damage. Look for things that are disconnected. Look for damage that may have been caused by rodents, insects, bugs. Look for damage that may have been caused by chafing. This unit does vibrate, and if a wire is pinched or is touching another metal area or any kind of area like a clamp or something, it may become chafed, meaning that the jacketing, that the insulation may be broken off, worn off, shaved off through the vibration. So make sure that you know that wires are not touching the metal inside of the frame or the chassis or another wire. So if you need to take some clamps off, any straps off, if you need to untie zip ties or cut zip ties or any kind of fastening device, make sure you do that so you can spread the wires. Make sure again that there's no power anywhere here, and you spread the wires and inspect them one by one. Make sure everything's connected as it appears to be connected, or it appears to that it should be connected. Of course, if you can find a wiring diagram using the model I provided, it's even better. That way you know exactly what goes where, but everything should be connected or close to its connection point if it was working. So if a wire comes loose, it should be very nearby to where it came loose from, and you may be able to just reconnect it, repair it. Make sure that also you check these wires right here, the ones with the wire ties, wire nuts. If it's a bunch of thin wires, multicolors, different colors, about 6 to 8 of them, maybe more, they probably are your wires coming from your thermostat. Make sure all of those are tied. They should match the color that they're tied to, not necessarily, but most of them should. Make sure that they're all tied and they are securely tied. Some of them may have come loose through vibration, or maybe by taking the panel on and off. It may have been pinched in the panel when someone put the panel back on. Who knows? So once you check all those, make sure that there's no damage on the wires and put them back together if necessary. Move on to this board, this control board shown here. Make sure all these connections are put on all the way in correctly. Make sure there's no damage on the wire. Make sure none of the connections are loose. And more importantly, make sure that this fuse is good. Take the fuse out and check it. Make sure the fuse wire, the little conductor in the middle of the fuse, is not broken. Make sure it's intact. You can look and see if it's burnt or broken inside, and you can also test it with a continuity meter or multimeter on continuity mode. So make sure you do that. This is an example of that fuse. It's a 3 amp fuse, purple, and that fuse is broken. You can see in the center the broken wire or conductor and a small burnt spot telling you that that fuse has been blown. That's that board again. If you suspect or find out that that board is bad, you can replace it. Check the part number, take the part number and order it online, or maybe at a electrical supply store, but most likely online. That's probably where you're going to find it the cheapest. And of course, that's after you replace the fuse and you may have found out that the board is still bad. Maybe the board looks burnt, has a burnt spot, looks damaged in any way, any of the components. It has a lot of resistors, perhaps some capacitors, and coils or chokes. You may have other components. So make sure all those components are intact. Inspect the board from front and back. Make sure that, again, there are no damage, obvious damage to it. If you suspect in any way there's damage, I would replace it. Then move to this relay. In my case, I found this relay bad, faulty, and burnt. If you can notice, this big neutral cable or wire that goes connected to that terminal is completely burnt, as if it caught fire, as if it sparked and arced. It may have been, most likely, because it was loose. When a wire, especially these thick gauge, high amperage, high voltage wires, are loose, they start to arc, spark, and heat up extremely hot and burn. That appears to be the case here. It may have been a surge, it may have been a lightning strike, who knows. But if you can see that area that has been burnt. So make sure that you go through every connection. Make sure they're all tight. If there's no damage, physical damage to this relay, make sure all the connections are tight and all the connections are on all the way correctly, and that the wiring is not chafed, damaged, cut, burnt in any way. In my case, I had to replace this relay because it was just damaged in the wire, this neutral wire that connected here at the bottom left. I had to just trim the burnt wiring out and basically just reinstall it. So I had to remove this relay. Before you remove any component like the relay board or any other component that has a few connections, make sure you note the connections, label the connections if you can, draw the connections or mark the connections in one way or another. In my case, I did both. I labeled each wire and I made a small diagram sketch that tells you each connection, just in case anybody else needs to in the future replace that relay or work with this relay in any capacity. And here is shown another view of that burnt wire and the damage it caused. I would take photos if you can of the components as you work with them. That way you know what wire went where. That's another way of making your connections once you replace the part, and that way you won't have any problems. You can use these photos as a reference. Take photos of different angles, of course, covering every connection. So this is the wire diagram that I sketched to help me make the connections quickly once I replaced the relay. There you can see I have already removed the relay. And here you can see the extreme damage done by the wiring there, and it looks like it caught fire there briefly. Luckily the fire did not spread. And you can see here I have connected and installed the relay. As you can see, there are multiple labels on every one label for each wire, telling me where on the relay that wire is connected to. As much as I could, I labeled everything, and additionally I sketched that diagram. That way there's no problem when it comes to the connections and the unit working. So I put the board back on the way it was, and after I inspected it, I replaced the fuse, 3-amp fuse. I installed the relay, made all the connections as they were, and repaired the burnt wire by trimming the burnt part, just putting it back. Once you do all that, make sure all your connections are correct and tight. You don't want to miss wire any connection, so make sure you verify and double check. And the unit worked after that. Of course, I had to do some other work on the outside unit, and not necessarily because that was the problem, but also because I was troubleshooting and trying to find the problem. So the problem was mainly that one relay, but I did find some other issues with the system. Again, in my case, the system would not come on at all. The system would just not respond to the thermostat inside. I checked for power, checked for tripped breakers, checked for fuses, and those were not the problem. So I had to go inside of the units and check. So we'll move on to the outside unit, and we'll check the control board, the capacitor, and we'll check those and repair those as necessary. So before, again, you do any work, locate the unit's disconnect, and before you even check the disconnect, make sure you turn the breaker off, the electrical panel breaker that's inside of your home most likely. Make sure you turn that breaker off that is specific to this outside unit or to the AC units in general. There may be more than one breaker. Make sure you shut them all off. Once you shut the breaker off, come back outside and locate the disconnect for the unit. You can tell by the cable or wire going to that box. Locate the box, open it. Once the breaker inside of the house is off, there should be no power here, but just as a precaution in case anyone ever turns that breaker inside of the house back on, you need to shut off the disconnect. Disable the disconnect by pulling, in this case by pulling this tab. Your disconnect may look different, may be operated through a lever or any kind of other mechanism like a fuse, whatever. Make sure you remove the tab, shut the lever to the off position, and to remove the fuse or fuses. Safely remove the fuse or fuses using, if you're going to remove a fuse, make sure you use insulated tools. So that is shown when the disconnect is disabled or disconnected. That in this case, in this model, this tab is off, so now there should be no power that goes to your unit, where if a power surge or the power was to be turned on suddenly, there would not be any power going to the unit while you're working on it. This is the unit that I worked on, the model. Again, it's the GSZ140361KE. Again, your unit may be slightly different, maybe different size, different voltage, whatever, but the troubleshooting steps may be similar, and it may help to follow them. You want to, again, before you remove any panels, check, make sure there's no power with a voltage tester. Make sure that you, with the voltage tester, test here. Make sure there's no voltage going in or out here. And once you test that, make sure there's no power going into the unit. You may be able to test it with your tester through this cable right here. You may not be able to test it because of the conduit. The tester may not detect any voltage, but if that is the case, you can remove the panel. I believe there are about 4 screws or bolts for you to remove. Once you expose this, you have to use your voltage tester and test. Make sure there's no power here at all. If there's any power, then you have not followed the steps that I gave you just now. Prior to this, make sure you go back and shut off your breakers and disconnect your unit disconnect. So this is the capacitor. This can looking device, or the starter, and often it's the case that causes the unit not to come on if it goes bad. Sometimes you can see damage to it. Sometimes the top may be blown out or warped, or ballooned up, bubbled up, whatever you want to call it. A lot of times it's just internally faulty, where you cannot see any damage or faults outside. You may see it as being very old, sometimes corroded. So that is also a sign that it may be bad. You may be able to test these. There are ways to test these, and you can look how in other videos. There are tests that you can make, that you can do to see if this is working or not. Some of those tests are not so reliable unless you have the correct and specialized tester or meter. But there are some tests you can do to find out if there's a chance that this can be bad. If you suspect that it's bad, I would just recommend swapping it out, changing it. These things run from maybe 20 bucks and up. So this is the capacitor for this specific unit. The part number is there on the left side. You may order it online. You could purchase it at a electrical supplier, but most likely you'll find a better deal online. There are usually 4 connections for 4 wires, as you saw here. There's a red wire. In this case, your unit may have different color wires, but this unit here has red, yellow, purple, and brown. I marked them, and to make sure that I connected them on the right spot once I replaced it. In this case, the red goes on the left side of the connection, or the terminal is marked with a C. That C, I'm not sure if it means common or coil, but it's marked with a C, and the red goes on the left side, the purple goes on the right side of the terminal marked with C. The yellow goes on this one here that doesn't have any markings, and the brown goes on this terminal with a single connection marked for the fan. Once you replace the capacitor, and the unit may or may not work at that point. If the unit works fine, the problem was the capacitor. In my case, there was other issues, and I kept on troubleshooting and trying other parts. So I decided to check this control board. This control board basically controls the outside unit's motor and other functions. So check the board, check for damage. In this case, I found a spot on it that looked browned out. That's usually a sign of problem. So I decided to swap out this board, get one online, replace it. Before you swap out the board, you again want to note every single connection on the board, mark the cables or label the cables in any way you can. I labeled each cable with a piece of tape and noted the exact location where it went. Each location is got a name to it or a label. It may be a few letters to it, it may be one letter label. To make sure you label these wires and connections, that way you know where they came from, and so you can connect them back to the right spot without problems. Once you check your board, replace it if you need to, check the relay on this unit. There's a few wires and connections going to it. Make sure that the wires are not damaged, there's no burnt spots. Make sure the relay is not physically damaged. You can see, you know, burnt marks, burnt spots. Make sure the plastic is not broken or burnt. Also make sure all of these screwed connections are tight. Make sure the wires are not loose, and these spade connections are on all the way in and tight. If you don't suspect this relay is bad, doesn't have any sign of damage, then it may be good. If you change the board and the capacitor and the unit's still not coming on, and there is no other issue with power or anything else, then I would replace this relay. The relay may be faulty internally. Again, this is another view of that board and all of the connections to it. There's quite a few. Make sure that you label each and every one of them. Also, the wiring coming from the thermostat, again, is a few thin wires, maybe about 6 or 8, and make sure that they are making contact. I would remove these wire ties and make sure the wires are making contact with each other. The copper metal is making contact with each other, they're secured, they're not loose or coming off. Make sure that your connections are on and tight. You may not have wire ties, you may have crimp-on connections or other type of connection. And again, the wire colors may match, as you can see here in these 3, but they may not match, as you can see here in these 2. These 2 gray wires are connected to a blue and a yellow. Also, there may be other wires that are not connected. It depends on your thermostat, the model, what type, and how it's wired or should be wired to your unit. Make sure that you are familiar with this if you're going to take these off and fiddle around with it in any way. And make sure you do have the wiring diagram for both your unit and the thermostat, or look for help. This is another view of the control board. You may remove the board and get the part number. As you can see, this one here had a burnt mark on the rear and front. That's why I decided to replace it. I believe the part number in this case is this one here on the bottom. There's a chance it may be this one here on top. And then, just once you have replaced all of your parts, the unit should run. In my case, the unit was fine after replacing the capacitor and the board. I believe these parts may have been okay, and the relay on the inside unit may have been the main problem, but I went ahead and replaced those anyway because of the discoloration or burnt mark on that board, and just because the capacitor is usually some of the things that go bad on these units, so I just went ahead and replaced it. That way it has a fresh new capacitor for years to come. Thank you very much. This has been a complete electrical repair for the Goodman ARUF37C14AC. That is the inside unit, and the GSZ140361KE GSZ140361KE, the outside unit. Thank you very much. I'd like to hear your comments.